Okay, this is lesson 19. I can solve problems by analyzing different unit rates given in tables. So they'll give us some ratio tables, given equations. So we might see something like y equals 4 times x. And then graphs. So we have been using a little bit of graphs lately where we know this is the y-axis, this is the x-axis, and we'll see some plotted points. So we're going to be analyzing these three tools in order to compare different unit rates. Let's get started. The ratio of cups of blue paint to the ratio of cups of red paint is 1 to 2. Which means for every cup of blue paint, there are 2 cups of red paint. In this case, the equation would be red equals 2 times blue, or it's a funny looking R. R equals 2 times 2B, where B represents the amount of blue paint, R represents the amount of red paint. Make a table of values. So here's some prompts and questions I see to kind of help me draw the table. If we have 1 cup of blue paint, how many cups of red paint? So let's label, we've got cups of blue paint here on top, and then we've got cups of red paint below. Cups of blue paint, cups of red paint. So if we have 1 cup of blue paint, I can tell in my ratio that I would have 2 cups of red paint. Okay, I see my constant here. I know that I'm multiplying by 2 going that way. That would be my constant all the way across. If we have 2 cups of blue paint, how many cups of red paint? Well, 2 times 2 is 4 cups of red paint. 3 times 2 is 6. And 4 times 2 is 8. So we've completed the table. Examine the table and identify the unit rate. That means what are we doing to, how many of one to get the other? So the unit rate is going to be 2. Where do you see this value in the equation? Well, I see this because it's the value by which we are multiplying the cups of blue paint in order to get the cups of red paint. So I could write that. It's the value by which the cups of blue paint, like when we have 1 cup of blue paint, we're multiplying it by 2 to get the cups of red paint, or the amount of red paint. So by which the cups of blue paint are being multiplied. Miss Sipple is a librarian who really enjoys reading. She can read 3/4 of a book in 1 day. This relationship can be represented by the equation days equals 3/4 books, which can be written as D equals 3/4 B, where B represents the number of books and D represents the number of days. So let's go ahead and complete a table for that. Again, the 2 things being compared is the number of days to the number of books. So because days is mentioned first and then books is mentioned second, we're going to keep it in that order for our ratio table. So number of days to number of books. Okay, so in just 1 day, she can read 3/4 of a book. So 3/4 of a book in 1 day. And honestly, if we would have flip-flopped the order, it wouldn't have made a difference. I just want to make that clear. So every time, one thing I'm noticing here is every time I'm multiplying by 3/4 from the number of days to get the number of books. That's because that's the value. Okay, so if I have 2 days, I can multiply that by 3/4 and get 6/4, which is an improper fraction, so I could also write that as 1 and 2/4 or 1 1/2. If I have 3 days and I multiply that by 3/4, 3 over 1 times 3/4, I would get 9/4. Again, that's an improper fraction, so I could also write that as 2 1/4. And then if for 4 days, I would do the same thing, multiply by 3/4, 4 over 1 times 3 over 4, and I'd get 12/4, or as a whole number, 3 wholes. 3 whole books in 4 days. And when I look at this value, like saying, okay, 3/4 of a book in 1 day, I can find the ratio of being 3 books in 4 days. So we can really take the fraction, the value, and determine the ratio, the whole numbers in the ratio from there as well. Okay, so for the next one, it says Brian and Shanice are both training for a bike race and want to compare who rides his or her bike at a faster rate. Remember, guys, when they say rate, they mean like per 1 unit. So who can ride the bike, who can ride how many miles in just 1 hour faster? That's going to be the faster rate. Both bikers use apps on their phone to record the time and distance of their bike rides. So Brian's app keeps track of his route on a table. So for Brian, we see this ratio table here. For Shanice's app, it presents the information on a graph. So here we have a graph of hours versus miles, and that's representative of Shanice's data. The information is shown below. So A asks us, at what rate does each biker travel? There's that word again, rate. They want to know how many miles in just 1 hour. So for example, Brian's table doesn't give us that information. I see 75 miles in 3 hours, but to find the rate, I want to know how many miles in just 1 hour. So something that we recognize by looking at these patterns, I know if I take if I take the number 3, I need to divide it by 3 to get 1. So the same deal here, I need to take 75. I'm going to divide that by 3, and whatever that is the rate in which, how many miles Brian travels in 1 hour, his rate. So 75 divided by 3, and I kind of can think of this in terms of money, but I'll go ahead and do the division anyways. So 3 goes into 7 2 times, minus 6 is 1, bring down the 5. 3 goes into 15 5 times, so 25 miles per hour, and that is for Brian. Brian goes 25 miles per hour. 25, I just plug that in everywhere. Now for Shanice, her graph shows us where 1 hour is. So I'm looking at that point on the graph, and if I say, okay, here's where 1 hour is, let's see how many miles. That looks like it's right here halfway between, let me zoom in for you guys to really see. That point would be right halfway between 10, which is here, and 20, which is here. So halfway between 10 and 20 is about 15. So let's say that point's at about 1:15. So this being the number of hours, and this the y-axis being the number of miles, she rides about 15 miles in 1 hour. Shanice, 15 miles per hour. Okay, now here it asks you to explain how you arrived at your answer. So on your paper, you're going to explain something to do with, well, what we did here is with Brian's, we divided both the numbers in the ratio by 3 to find the rate. And with Shanice, we looked at the coordinates on the graph and saw that the y coordinate for the x coordinate 1, the y coordinate was at 15. So we were able to determine by looking at the graph that the coordinate was at 1:15 for Shanice. Now for B, it says Shanice, she wants to win the bike race. Make a new graph to show the speed that Shanice would need would have to ride her bike in order to beat Brian. So right now, you guys, Brian, he's traveling, let's look back. Brian's traveling at 25 miles per hour while she's only traveling at 15. So if she wants to beat Brian, she needs to go faster than 25 miles per hour. So one easy thing, way to do a graph is, let's just say she's gonna ride 26 miles per hour, or you can graph it at 30 miles per hour. I'm gonna do mine just at 30 miles per hour to show that she would ride it faster than Brian. So I'm just gonna go up by 30s, 30, 60, 90, 120, 150, that's enough. And then 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. This is hours, this is miles. Okay, so 0, 0. At 1 hour, she could go 30 miles per hour. That would beat Brian. 2 hours, 60. 3 hours, 90 miles an hour. 4 hours, 120. 5 hours, 150. And just keep going at that same constant rate. And she will beat Brian.